when we were writing the Space Act agreement and negotiating with NASA on the definition of the milestones. We purposely kept them top level and kept them vague. That was a key to the whole paradigm here, to get commercial companies to step up and provide the service commercially to NASA. Required that NASA stay at a top level and not dictate and flow down requirements all the way down A level spec, B level, C level, and prescribe the design, approve design changes, and so on. I think to really leverage the power of a commercial entity such as ours to make decisions, do make-buy decisions, bring stuff in-house, go to different vendors. This isn't working, switch to that one quickly. Maybe I'll turn on 2 vendors for risk mitigation with the same design, see which one wins, and then down select. That kind of maneuvering we can do much more quickly than NASA can. So I think they kept up their part of the bargain, which was define top-level performance requirements, get cargo from the ground to the station, and keep it safe. And then the only real flow down of specific workmanship type requirements or detailed technical requirements were with regard to the spacecraft and the necessary safety requirements for approach and safe berthing with the space station and then departure, and operations while attached is obviously a huge human safety component there, and that had to be flowed down. So that was more of a traditional, flow down. But in terms of the launch vehicle that I worked on, there was very little in the way of prescribed design or technical requirements on the launch vehicle. All of our requirements came from Cygnus, so these top-level performance requirements were decomposed by Cygnus and then levied on the launch vehicle in terms of what the upmass needed to be to what orbit, what inclination, what are the environments needed to be, defining the ICD between the rocket and the spacecraft. All that was left to commercial industry, and I think, as has been proven, over the many years of commercial launches, the commercial industry is capable of getting things to low Earth orbit. And I think NASA was right that they could count on that with a very small, lean insight rather, from this COTS project team and get the result that they were looking for. The benefits of a commercial approach like this, where within the company we took the top-level performance requirements and decomposed them, assigned them to spacecraft or launch vehicle, it allowed us to really have the flexibility that we needed to make design trades. One of them was whether we needed a third stage, and that would have enabled the spacecraft to be smaller and the rocket would have been a little bigger. We actually found out that if we treated the spacecraft like a third stage, in other words, took advantage of its very powerful and capable propulsion system, a biprop propulsion system, which is typical for medium-class spacecraft of this type and highly maneuverable, by treating them like a third stage and having both the launch vehicle and the spacecraft in-house, we were able to devise a trajectory that dropped the spacecraft off at a very low altitude, just above the atmosphere. And it would require, in certain dispersed cases, for them to wake up the spacecraft and burn earlier than they were used to. But that really provided a lot more performance when we thought of the integrated piece as a whole, rather than a traditional, okay, we're going to stop the launch vehicle part and start the spacecraft part. We considered it as an integrated mission on getting cargo to the space station. I think having that complete system under the purview of a single commercial design entity enabled that kind of result, which was very powerful.